Advanced Math Lesson 8, Part A is about statements of similarity. So it says, when making a statement of similarity, you must list the vertices so that corresponding angles are listed in the same order. They would be the ones that are congruent to each other. In the diagram here, we have, like, those are each right angles, angle E is triangle, and angle J over here, they're congruent. These have, instead of tick marks, they have little curves. This has two of those, and this has two of those. So those two angles are congruent as well. And so when we have the two different triangles where the angles in this one are congruent to the angles in the other one, those triangles are similar, and that means we can make this. And so I'm going to write triangle DEF. Okay, and that looks like a tilde. That is the symbol for is similar to. I suggest writing that in your notes, is similar to, and then we're going to put triangle. Now, when I name this one, I need to name the congruent angles in the same order. So I started with D here, which is a right angle, so I need to start with L. And then E just had the one little curve, so I need that here. That would be J. And then F had the two curves. I need the one with the two curves, and that's K. Because of how I named the first one, that is how I must name the second one. The congruent angles need to be listed in the same order. Now, I didn't have to be alphabetical in the first one. I could have said angle EFD. Triangle. EFD is similar to triangle. And now that I already have this once, I can see E matches up with J, F matches up with K, and then D matches up with L. And now I know I know for that one I have the congruent angles all listed in the same order. Okay, you could not jumble them up. Like, you would not say that triangle FED is similar to triangle JKL, because F matches up again with K. I would have had to start with K. That is not what you write. You would not write it like that. Okay, when we have one of these written correctly, it also shows us which sides of the triangles are proportional, because the corresponding sides are automatically listed also. Segment DE corresponds with segment LJ. So DE here goes with LJ here. Alright, so I'm just going to stick with this first one. This tells me, and it could have been the second one, doesn't matter, but this tells me segment DE over segment LJ equals the measure of segment EF over JK, which also equals DF, taking the first and the third, over LK. I can take any two of these and make a proportion. But all of these, if we had numbers for the sides, they would all reduce to the same number. That's what it means by them being proportional. Okay. Now, in example 1 here, there are three triangles over here. But this says in triangle ABC, so the big one, BD is the altitude to the hypotenuse AC, which is how we know this is a right angle as well. The altitude is the height. It's a perpendicular distance from that vertex to the opposite side. Okay, now, when you have one of these, and if you notice what you're supposed to show, okay, they have two sets of sides being equal to each other, or being proportional. All of these have an A in it. So I know the two triangles I'm looking at over here have to have A as a vertex. However, that won't always be the case. I want to show you a way to do this generically that will always work for these problems. I'm going to redraw all three of the triangles. Okay, so A, B, D, that's the one on the left. And I'm also going to put some tick marks in here. Okay, because these have to be similar triangles. Let's look at the one on the right. But I'm going to turn them all the same way. Now, each of them has a 90-degree angle, right? And two of them have that angle A. Let me draw the other one. And if I'm turning them so corresponding angles, well, the congruent angles are all lining up, I have to do that. Between the one tick mark and the two tick marks on the large triangle, that's the hypotenuse, that's here. So this is AC. And the two tick mark is that's angle C. The right angle of this one is D. The other angle has to be B. And I know these angles are congruent because all angles in a triangle add up to 180. So all of these are similar. There's B. I have all my vertices labeled. And now I look at this proportion and find those segments over here. AD is only on this small triangle. Okay, there's no side AD on either of the other two. So I know the small triangle is going to be named in my statement of similarity. And let's see, AB is showing up twice. That's here and here. So I'm using the small one and the big one, ABC. So they're the ones I'm naming. Triangle ABD is similar to triangle, and now I need to make sure congruent angles are listed in the same order. So A, and then B is the other acute one, so that's C, and then I did the right angle last here, so I'm doing the right angle last there. That is my statement of similarity. And that's all I need to do to show that. If two triangles are similar, then their corresponding sides are proportional. And so that's all I need to do for this. I just want to demonstrate though. AD, okay, that was here. So the first and last over AB. And then here we have AB over AC. They match up. That's it. That's all you need to write for that. Now, in part B, this is about proportional segments. It says we're going to prove something. So we're supposed to prove that two parallel lines, like we have here, cut proportional segments from any two intersecting transversals. So here we have two transversals, lines that are crossing our parallels, and those transversals intersect. That's what that's talking about. Now this is, we're supposed to be saying then that the sides, well, the segments are proportional. What we have here is two overlapping triangles. Okay, parallel lines cut by this transversal means these corresponding angles are congruent. These parallel lines crossed by that transversal means that these corresponding angles are congruent. And this angle on top is in both of the triangles. These are similar triangles. Okay, but we're supposed to prove that these segments are going to be proportional. Okay, so in order to do that, we need to remember something. It's just from part A, so it shouldn't take too long to remember. Is these proportional segments on these triangles. So here we go. I'm going to redraw these. Rough sketch. Alright, so on the small one on top here, this is A, this is C. On the larger one, this side is A plus B, and this one is C plus D. And we know if these are similar triangles, which we already know, that those sides of those triangles are proportional. Therefore, we could say A plus B over A, okay, left side over left side, equals right side over right side. And then we just need to simplify these. This is the same as A over A plus B over A equals C over C plus D over C. We know that anything other than 0 divided by itself is 1. Right? So this is 1 plus B over A equals, and here we go again, 1 plus D over C. Subtracting 1 from both sides, we would have B over A equals D over C. B over A equals D over C. We have just shown that those segments are proportional. We proved it. Okay, now there's a diagram over here. Just to point out, we could have any number of overlapping similar triangles, and so we could kind of extend that into this longer version of this. It's also true, for more than two triangles. So A over B equals D over E, but also B over C equals E over F, and so on. Any of these we can say are proportional because they are similar triangles, and that's all we really probably should have to say about that. In example 2 here, find x. We need our diagram first, so let's put that in here. We're going to have 3 parallel lines crossed by 2 transversals. Okay, here are my 3 parallel lines. I kind of missed. There. Crossed by 2 transversals. See, if this extended, we would have a bunch of overlapping similar triangles. And let's see, we have x plus 1 is the segment right here, and the one below it is 13. And then the segment here is x plus 4, and the one below that is 19. And we're going to take this knowledge that when we have parallel lines crossed by the 2 transversals, the segments are proportional. And so we can write a proportion and then solve it. So that would mean x plus 1 over 13 equals x plus 4 over 19. And then I'm going to multiply 19 times both sides, which cancels this one. And I'm going to multiply 13 times both sides, which cancels that one. So we would have 19x plus 19 equals 13x plus, let's see, 40 and 12, 52. Get the x's all on one side. If I'm moving x to the left, I'll be needing to remove that 19. Okay, so here we have 6x equals 12 minus 9 is 3, 4 minus 1 is 3. Divide by the coefficient, that reduces. Looks like 11 halves is x. X is 11 halves. So we're using our proportional segments and then just solving that equation. Okay, I also didn't give you much for part C. We have to draw here as well. Angle bisectors and side ratios. I think you're going to like this one. So we're going to have a triangle. It's not, it could be scalene, it's no special triangle, it's just a triangle. And let's see, that side is length A, here's B, and on the bottom, okay, so we're going to have an angle bisector. That means this angle is being bisected. That is congruent to that. This line is the bisector. when we have this, that splits the other side into two segments. We're going to label C and D. And any time this happens, here's what you're going to like. A over C, like it's almost set up for you, A over C equals B over D. This is what happens. Okay? You'll be able to use this. You'll be given a triangle like this, but only, 3 numbers and 1 variable, and then you solve for the missing part. There's an optional proof. I encourage you to read. It's on page 64 in your book. Okay? I'm not going to make you read it. I'm not going to make you spend time with it in the notes video. We're just going to do an example with some actual numbers in it, and then be done. There are 2 examples in the book. I think we'll just do one here. So this would be example 3 for our notes. I'm going to actually be doing example 4 from the book. And the reason is the triangles turned funny, and so I want you to be prepared for that. So, we're going to find x for this particular triangle. Okay, I made that a little long. Okay, so here's our triangle. This is triangle A, B, C. And this side is 20. Our x is here. And this time the bisector is going to be here. Okay, this is the angle being bisected. The bisector is that segment AD. Alright, this side is, or that segment is 6, and this one is 14. And we're supposed to find out what x equals. Okay, so you need to remember this thing works whenever the bisected angle is basically like the top. So what we really have is 20 over 14 equals x over 6. You can turn it if you want to. Now, I'll also say on the thing we had in the top here, the generic one, I could have written A over B equals C over D. It is equivalent to this other one. You could take it either way. But just don't let it get you messed up when the triangle is turned. But this is what we have. 20 over 14 equals x over 6. Solving for x, I can just multiply both sides times 6, because then x is by itself. This gets reduced, and then that'll be the answer. So let's see. That divides evenly by 2. That divides evenly by 2. Nothing else reduces. Looks like 60 over 7 equals x. And that's how they're done. That's the end of your notes. Again, I encourage you to check out that proof on page 64. Have fun with these problems.